this? I mean, are aliens spying on us?
Well, this is the third object from outside the solar system that was spotted on July 1st, 2025, and it was anomalous in many ways, one of which is its size. It's bigger than 5 kilometers in diameter, comparable to a major city. And in addition, it follows a path that is aligned with the ecliptic plane of the planets around the sun. And it had additional anomalies, altogether 10 of them.
So we finally have our first clear look at Comet 3 I/ATLAS after it disappeared behind the sun. And honestly, it's causing quite a stir among astronomers. Now that it's re-emerged, an astronomer using the Discovery telescope at Lowell Observatory, and even his own smaller telescope, has managed to capture new high-quality images of this mysterious interstellar traveler. These shots are believed to be the very first optical observations of 3 I/ATLAS since it vanished from view. What makes this such a big deal is that this comet isn't just another icy rock drifting through our solar system. It's an interstellar object, a true outsider from another corner of the galaxy. And its behavior right now is turning out to be anything but ordinary. It all happened around October 29th, 2025. While most people on Earth were just going about their regular day, a bunch of telescopes all over the planet were fixated on one tiny point in the sky. That point, as it turns out, was this interstellar visitor making its closest approach to the sun. And what scientists saw next didn't fit the usual script. It didn't explode and it didn't disappear either. Instead, it started glowing brighter, much brighter than anyone expected, defying predictions in ways that have everyone scratching their heads. Only a few days later, about 72 hours after this strange brightening began, the United Nations did something completely unprecedented. For the first time ever in the history of space monitoring, they activated planetary defense protocols specifically for an interstellar object. That's not something that happens lightly, so clearly this comet is doing something worth paying attention to. Now let's break down what's actually happening. When astronomers tracked 3 I/ATLAS as it swung past the sun, their instruments caught an unexpected spike in brightness. Normally, comets follow a smooth, predictable pattern as they heat up near the sun, brightening gradually, then fading just as smoothly. But this one's brightness shot up faster than expected, about twice the pace that earlier models had predicted. Observations from astronomers like Tong Zhang at Lowell Observatory and Carl Bams at the Naval Research Laboratory confirmed this rapid surge, and it immediately became a hot topic in the astronomy community. The reason this is such a big deal is because 3 I/ATLAS isn't just some random piece of icy debris left over from the solar system's formation. This object has likely been drifting through the galaxy for somewhere between 7 and 12 billion years. That's 3 times older than our planet and even older than the sun itself. Think about that. This thing has been out there surviving supernova blasts, cosmic radiation, gravitational tugs from countless stars, and billions of years of exposure to everything space can throw at it. And despite all that, it's arrived here looking mostly intact. But now, right in our neighborhood, it's behaving in a way that doesn't fit what we know. When scientists studied its light spectrum, they realized something remarkable. The light wasn't just reflected sunlight bouncing off its surface. The comet itself was actively emitting gases, carbon compounds, and water vapor at levels 40 times higher than they'd seen just a month earlier. It's as if someone suddenly turned on a faucet deep inside it. But here's the problem. Comets don't work that way. They don't suddenly flip on like a switch. Usually, as they move closer to the sun, their ice slowly warms and starts to evaporate, producing a steady, predictable increase in brightness. But this sudden jump defied that logic completely. Space observatories that specialize in watching near-sun objects, like SOHO, STEREOA, and GOES, caught images during its closest approach. These photos confirmed another odd detail. 3 I/ATLAS was glowing, its shape appeared elongated, but there was barely any visible dust. That's unusual because dust is what makes comets spectacular in the first place. It's the dust tail that catches sunlight and creates those beautiful glowing trails we see in the sky. So when a comet gets that bright without much dust, it's immediately suspicious. Some researchers think they might have an explanation. They suspect that earlier in its journey, the comet had a layer of frozen carbon dioxide acting as a kind of protective shield. Carbon dioxide sublimates, or turns into gas, at lower temperatures than water ice, so it could have kept the comet's surface cooler than expected. But once that layer burned off near its closest point to the sun, the water ice underneath would have been suddenly exposed. That exposure could have caused the surface to heat up all at once, triggering that sudden brightness surge. It's a theory that fits known physics, but it also suggests that the comet's internal structure is unlike anything we've seen before, a sort of layered makeup that no comet in our solar system has ever shown.
Things are getting very wild.
Yeah, there is a lot of misinformation. Some people said, I invented 3I Atlas, this object, in order to distract attention from the Epstein files.
That, of course, raises even bigger questions about where this object came from and what kind of environment it formed in. Because if it was born around another star system, that system must have had conditions very different from our own. To add to the mystery, the James Webb Space Telescope observed 3I/ATLAS months earlier, back in August, before this brightening even began. Webb's instruments are precise enough to read the chemical makeup of a comet's surface molecules. And the data it sent back revealed something even more puzzling. The outer layer of 3I/ATLAS has been heavily altered by cosmic radiation, not from our sun, but from deep space itself. Radiation from distant supernova explosions and other cosmic sources has been bombarding the comet for billions of years, penetrating its surface and reshaping its molecular structure. According to Roma Maggiolo from the Royal Belgian Institute for Space Astronomy, computer models suggest this radiation has created a thick crust, roughly 50 to 65 feet deep. That means what we're seeing now isn't the original surface from when the comet first formed. It's a weathered, processed shell that's been slowly transformed over time by cosmic exposure. And that's important because scientists originally hoped that interstellar visitors like 3I/ATLAS would give us a glimpse into what other star systems are made of. If we could study their pristine material, we could learn about planet formation elsewhere in the galaxy. But if what we're seeing is just a radiation-altered crust, then that original material might still be buried deep underneath, untouched. Unless the heat from its close pass by the sun managed to burn through that crust and expose the fresh material below, we might not get those answers just yet. That's why researchers all over the world are watching closely now. The next few weeks of data collection could reveal whether the solar heating stripped off some of that ancient shell or if it's still fully intact. But the story doesn't stop there. It actually gets even more interesting. On October 21st, about 8 days before the comet's closest approach, the International Asteroid Warning Network, or IAWN, made an unexpected move. They announced a global observation campaign targeting 3I/ATLAS. The campaign was scheduled to run from late November 2025 through January 2026. Now, the IAWN conducts observation drills pretty often, about once a year since 2017, to practice tracking potentially hazardous objects like asteroids that might come too close to Earth. But here's the twist. They've never, not once, focused one of these exercises on an interstellar object. This is literally the first time in their history that they've done so. Officially, they explained that the reason was technical. Measuring comets precisely is trickier than tracking asteroids because comets have fuzzy comas and tails that make it hard to pinpoint their actual cores. So the network said this was a perfect chance to practice those techniques on a challenging target. That's a fair and scientific reason on paper. But the timing of everything has caught people's attention. Just 3 weeks before this official campaign announcement, Harvard professor Avi Loeb submitted a white paper to the United Nations. Co-authored with researchers Omar Eldi and Gershon Tenenbaum, it made a bold recommendation that the international community should coordinate global observation efforts for interstellar objects, because in rare cases, they might not just be natural. The paper argued that some of these visitors could theoretically carry alien technology, so humanity should be ready to study them carefully and cooperate worldwide when such objects appear. Now, no one is saying outright that IAWN thinks 3I/ATLAS is artificial. But the sequence of events, the white paper in late September, followed by the sudden global campaign in late October, has definitely raised eyebrows. For many scientists, it's just a coincidence driven by good timing and curiosity. For others, it's a sign that the world is starting to take interstellar visitors more seriously than ever before. Right now, in early November 2025, the interstellar comet 3I/ATLAS is at a very special point in its journey. It's got this incredible vantage spot in space, perfectly placed to be observed just after its closest pass to the Sun, the point known as perihelion. That's when comets tend to be the most active, because the Sun's heat pushes their icy material to sublimate into gas and dust. The observation window opened on November 2nd and runs until November 25th, giving researchers a short but crucial stretch of time to capture data during the comet's peak activity. The JUICE spacecraft, originally designed for Jupiter system research, is now in a perfect spot to observe 3I/ATLAS. It's using an impressive bunch of instruments: visible light cameras, infrared spectrometers, submillimeter wave detectors, and particle sensors. Basically, it's watching this visitor in a way no Earth-based telescope can match, simply because of its viewing angle. On November 4th, JUICE will make its closest approach, coming within 64 million kilometers of the comet. That's close enough to actually resolve surface details and measure activity levels with remarkable precision. Close enough to detect phenomena that would be invisible from Earth's perspective. But there's a catch. JUICE is currently so close to the Sun that it has to use its main antenna as a heat shield, which means its data transmission is extremely limited. All the observations it's gathering now will have to stay on board until February 2026, when it can safely transmit everything back to Earth. So for now, scientists have to wait patiently, knowing that whatever JUICE has seen could hold the most detailed clues we'll ever get about this object. While that's happening, another important test is underway, one that could decide how we interpret all the upcoming data. On October 29th, the Atacama Large Millimeter Array, ALMA, detected something unexpected. 3I/ATLAS wasn't exactly where gravity alone predicted it would be. It was off by a measurable amount, about 4 arcseconds in right ascension. That's small but real, and it's been confirmed by multiple sources. This means the comet isn't just being pulled by gravity. There's additional acceleration involved, forces acting on it that go beyond the Sun's gravitational pull. NASA's Jet Propulsion Laboratory analyzed the data and found 2 clear components to this acceleration, one pushing away from the Sun and another perpendicular to that line. Both are measurable. Both demand explanation. The standard explanation is outgassing. When a comet's icy surface heats up, the ice turns into gas that jets outward, giving the comet a small but consistent push, kind of like a natural rocket engine. Professor LOEB ran the numbers and found that if this outgassing is truly what caused the acceleration, then 3I/ATLAS must have lost about 1/6 of its total mass during its close solar pass. Roughly 5.5 billion tons of material blown into space in just a few weeks. That's a staggering amount. And if that really happened, we should see clear evidence. A huge glowing cloud of gas and dust around the comet. That's where the upcoming December test comes in. Starting in mid-November, as 3I/ATLAS emerges from the Sun's glare and becomes visible again, telescopes all over Earth, professional and amateur, will be watching closely. Then on December 19th, when the comet makes its closest approach to Earth, about 267 million kilometers away, hundreds of telescopes will be pointed its way, from Hubble and Webb to backyard observatories. They'll all be looking for one thing: that gas cloud. If it's there, if scientists detect billions of tons of material surrounding the comet, then we can safely say that 3I/ATLAS behaves like a natural comet, just an unusually intense one. And that's that for today's video. Thanks for watching, and we will see you in the next one.